Hi, welcome back to part 2 of my black hole simulation video. I spent ages, and I mean ages, trying to get the gravity to work on my code, and it just would not happen. So I've completely refactored the code. Now it's object oriented. We've got the black hole object and the photon object, and then we create them in the sketch file. Basically, we have an array of photon objects, each with a y position, and a black hole object with a mass. Inside of black hole, we have a pull function, which is our gravity pulling the photons towards the black hole. I used this formula, except photons don't have mass, so I've just left that out because we can change the laws of physics, right?
Reality can be whatever I want.
Anyway, let's see what happens when I run this. Yeah, gravity! Oh, hang on, there's a problem. The gravity is changing the speed of the photons. It shouldn't be able to do that. The speed of light's a constant. Okay, so we're over here inside of the pull function. I'm new to p-vectors, this is my first time using them, so it took me a little while to wrap my head around them. What this function is doing is creating a vector force. Initially, this is the distance between the photon and the center of the black hole. We can then use force.mag to give the length of the vector as a scalar, just the length of the line between the photon and the black hole. This is what we use as r in our equation for Fg, force due to gravity. Now the vector is already pointing towards the center of the black hole, we just need to change its magnitude, using setMag to be equal to the force due to gravity. We then add this p-vector to our p-vector for the photon's velocity. Then, this is important, set the magnitude of the photon's velocity back to c, the speed of light. Yes, this is better. Now the photons stay at a constant speed, just like real life. I'll just adjust the code a bit to make the photons come back onto the screen with their original positions. Oh, I need to give them their original direction too. Okay, I think we're done here. We can see that the photons that are too close get sucked into the black hole. After a certain distance, they don't get sucked in, but their trajectory has completely changed. I wonder what this would mean for someone looking at the black hole. Would the image be flipped? I don't know, it's hard to tell in 2D. I'd like to try this again in 3D. Yeah, maybe we could send the pixels of a photo from one end towards the black hole, then see how they come out at the other side. Is that even possible? If it is, it's above my skill level. Maybe one day. Oh, I just remembered that the photon at 1.5 times the Schwarzschild radius is supposed to orbit the black hole. If we can make sure that's happening, it should improve the accuracy of this simulation. So let's just check what's currently happening to the photon in this position. Wow, doesn't orbit, but it's pretty close. It changes direction by about 90 degrees. So I'll just increase the mass of the black hole, which should increase the force of gravity on the photon. What the? It pulled it in less? Let's just make the mass stupidly big to see what's happening. Whoa, okay, right. The Schwarzschild radius is related to the mass too. That's why increasing the mass isn't directly pulling the photon more. That's okay, we'll just hard code in the radius. So it used to be 65. Yep. So when the mass is 65, Schwarzschild radius is about 50? Close enough. Now when we increase the mass, it should pull the photon more. Cool. Now it's just about finding the sweet spot where the photon orbits. Okay, wow, it looks like it's not going to actually orbit, but whatever, this is close enough. Let's send all the photons again. Ah, far out, it's slow as. Hold on. Oh, we didn't see any orbit. That's alright, I'll just send more. Whoa, cool. None orbited, but they got close. Alright, I think this is where we leave it. Thanks for watching, guys. I'll see you next time. Wait! I just had a thought. Black holes are cool, right? But what's cooler than one black hole? 2 black holes! Alright, let's do this. Why do I always do X and Y backwards? Whoa, cool. This is a little bit too neat. Let's have a look at the photons when the black holes are in random positions. Alright, see you next time.